Hey all, I hope you're having a great start to your Wednesday. Obviously today I'm gone, which is why I'm recording this video. To start off our notes for the day, what I wanted to do was kind of go over what we talked about yesterday a little bit. So to start us off, yesterday we talked about types of matter. So overall, anything that is made up of mass and made up of, or takes up space, excuse me, is made of matter. So if we look at our image here, we've got a Ford Mustang. Ford Mustang's made of a bunch of different types of matter. If we think about types of matter, it's made up of rubber, it's made up of aluminum, it's made up of steel, glass, many other things. Then we look at what it's driving on. It's driving on maybe a cement with guardrails in the background, and behind that is some grass growing and some trees. All those things made up of matter. Looking at our left, we got a cruise ship. Cruise ship is made up of lots of different things. Steel, for sure. It's floating in the water. Water is made up of H2O. In the background, we see the mountain. Mountains made of many types of different mixtures throughout. And then we got some more solidified water in the form of snow in the background, all things that are made up of matter. Bottom left here, we've got our fishes. Fishes are made up of lots of carbon and hydrogens and oxygen. They're floating around in the water, all things that are made up of matter. And then lastly, to show us here, we've got um, an atom there. And I'm going to change my color really quick so when I draw, you guys are actually able to see them. There we go. So within our types of matter, we've got two different types. Our first type here is going to be our pure substances. Pure substances are going to be anything with exact composition. If you remember what composition or something that is composed of means, that means that it is made up of that. So exact composition, all parts are made up of the same thing. So what that means is if I had a jar here of H2O and I split it up into 5 groups, each section there is going to be made up of water. You're never going to find it made up of carbon, each little section, H2O, all throughout. So no matter how you divide it, it's always going to be the same substance. That makes it a pure substance there. Some examples there we got are gold. Gold bars are made up of solid gold. We've got copper. Copper looks kind of unique there, but that is copper. We've got water, ice cold water there. And then lastly, we've got copper sulfate. Look at that blue color. Well, something I want you to notice here, this distinction between that blue color and this bronze color. Both of these are made up of copper, but for some reason, we've got a blue and a bronze. We're going to get into that a little bit later, but that's kind of unique. It's something I want you to pay attention to. So, within our two types of pure substances are elements and compounds. Elements are going to be one type of an atom, compounds, more than one type of an atom. So, elements, one type, compounds, more than one type. So, elements are going to have the same type and it's going to have the same atoms and the same number of protons in their nucleus. When I asked you guys yesterday, you all correctly identified nucleus is found in the center of our atom. Within each element, there's going to have a fixed amount of protons. If you remember what fixed means the same. So same amount of protons. So carbon's always going to have 6 protons. Hydrogen's always going to have 1 proton. If you look to your right, or hopefully you're in the classroom right now, if you look to the right on the wall is our periodic table. You should see a list of 118 different elements. We're not going to use, obviously, all 118. I'm not, I repeat, not going to make you memorize those, but I do want you at some point of this year be a little bit more familiar with our periodic table. So you guys came up with some list of elements for me yesterday, but if you look to that right of you, 118 different types, you could be saying maybe copper, you might be saying iron or gold or maybe you're even saying uh, calcium or nitrogen or oxygen. All those different types are elements there. Now, you may have been noticing I was writing all these little abbreviations there. If you remember from yesterday when we talked about symbols, symbols are your abbreviations for elements. You can think of it as either scientists being lazy or just not wanting to spend time writing lithium. Instead of writing lithium, we write Li, or instead of chlorine, we write Cl. Every single element has a unique symbol to it. So we are going to be looking at different symbols for your elements. Lithium, Li, you can probably figure out where that comes from. Chlorine, the L and the C, chlorine. So some of them make a lot of sense. So many actually are going to make sense, but there's a few that don't. For instance, W for tungsten, Wolfram in German, or PV is plumbum in Latin for lead. Another one, Cu for cuprous. Cuprous is going to be the Latin word for copper. So when we've got two or more types of elements combining together, we make a compound. Sometimes it looks simple like that. Sometimes it's maybe a more complex uh, atom. All of those are compounds. Notice we've got at least two types of elements. If it's two or more, that's a compound. Something unique about them, they're going to be in fixed ratios. You're never going to find H2O anything different than H2O, or H2O, if you remember, is water. Water is always going to have two hydrogens and one oxygen. Now, I told you before when we were looking at the coppers, I said kind of take note about the blues compared to the bronzes. This is because our properties of compounds are going to change. Our elemental copper, we remember, was the color bronze. But when we looked at the compound, it was blue. This is because when we combine multiple elements, they don't always keep their properties. In fact, often they don't. So if we look back to our example that I'm referring to, we got compound blue, and we've got elemental copper. Both made of copper, very, very different properties there though. Another great example, we talked about hydrogen's flammable, oxygen's burnable. Once again, they explode to form, but as a result, it makes something very, very harmless in water. Now, we also moved on to mixtures. All of what we've been talking about have been pure substances. So they're all under the same section. In fact, we've been doing pure substances, and we get elements, and we get compounds. Now we're on to our mixtures. Mixtures are going to be anything where the properties actually do vary and the composition is mixed. So if you remember when I took the water and I split it up into 5 sections. All of them were the same parts. But when I take a mixture, maybe if I take a salad and I split it into 5 or 4 parts here, I might have some parts that were red, but you might find that the right side is blue or the middle is pink. We can notice here, those are not the same composition. That's because when I separate a salad, you might pull out the lettuce, you might pull out the tomato, you might pull out the cheese, you might pull out the beans, the peppered onions, or the cucumbers. Notice how those are not going to evenly spread out very well. It's because mixtures are not the same throughout. So our first type here is going to be homogeneous. Homogeneous are going to be evenly distributed all the way throughout. And when they form together in a liquid, we call them something called a solution. Solutions are going to be homogeneous liquid mixtures. So we're looking here, Kool-Aid, homogeneous solution. We've got pop, homogeneous solution. these solutions are going to be made of very, very small particles, ones that you can't even see once they dissolve in the substance. And as a result of them dissolving, we cannot separate them by gravity or filtering. So what that's saying is no longer how long that pop sits, sugar is not going to sit to the bottom. It's going to stay all throughout. It's not going to go to the bottom. Filtering would be like if you used a filter paper. If you think about how you make coffee, those are filter papers. We can't filter out the different parts of Kool-Aid, so we're not going to be able to filter it the way we might do other mixtures. Another type of mixture we're going to deal with is your heterogeneous. These are a lot easier to separate here, and this is because they're unevenly distributed with these particles. Notice how we can see the strawberries and salad, and I think that's pineapple, and then we've got blueberries. These are all very distinct differences. In fact, we would say they're not evenly mixed. You can tell the different parts. That's what makes it a heterogeneous mixture. We're going to talk about two different heterogeneous mixtures here. First type is our colloids. Colloids are going to be mixtures that kind of appear homogeneous. They kind of trick us a little bit, and this is because they're small particle size, but in fact they are heterogeneous mixtures. We think about milk. It's kind of gross to think about, but milk is kind of chunky. There's different parts of protein, different parts of milk, different parts of fats. When I said milk, I was thinking the protein lactose. There's different parts that are water, all different parts that are mixed together, but they're not actually mixed uniformly, which makes them heterogeneous. What makes the colloids different than the thing I'm going to talk about next is I can't separate these by gravity or filtering. If you let milk sit outside, it's definitely going to go bad, but it's not going to sink to the bottom with chunks. The bottoms that form the stuff that forms at the bottom of chunks is actually the milk that has gone bad, but not milk itself. Fog, for instance, you can't separate fog. Eventually, fog deforms and it becomes either a water vapor or solid water on the surface, but it's never going to just separate by gravity or through filtering. So those are colloids. Then we've got suspensions. Suspensions are going to be these heterogeneous mixtures with large particles. These are the ones that you can see. So muddy water, you might be able to see different particles of dirt. Italian dressing, you can see all those different little clumpy, gross parts. That's what is made up of Italian dressing. So I remember when I walked around with that rock box yesterday, all those different parts of rocks, if you separate them, you can individually pull the rocks out of the mixture. That's what we call a suspension. So these can be separated both by gravity and by filtering. If I threw muddy water into a jar, eventually that mud's going to settle to the bottle. That's because of the act of gravity. If I had a sand water solution, I could pour that sand into a filter, and that sand's just a little bit too big that it's not going to go through the filter paper. And as a result, we could filter off that sandy solution. In fact, we might do that later this unit. Sandy solution, it's because they are suspensions. They are suspended in the water, but they will eventually separate or settle. All right, so what I want you guys to do is take a little bit of time here and list down similarities or differences. You guys have done Venn diagrams before of our solution, which is our homogeneous, and our colloid suspension, which is our hetero. So go ahead and list down into our Venn diagram. I'm going to come back in about 2 minutes here and we'll fill this out together. But go ahead and start filling out from that sheet I passed out to you yesterday. And I said about 2 minutes, but if you are still writing, plenty of time, go ahead and pause that video because I'm going to get started filling out this sheet with us here. So solutions, first off, are going to be the only homogeneous mixtures. We know colloids and suspensions are heterogeneous. I'm going to hyphenate that, just write hetero, but that means heterogeneous for us there. What else can we think about? Homogeneous are uniform. They're probably dissolved. We think about the similarities between solutions and colloids. One of the things that I can certainly think about is they are not separable by gravity or by filtration. Colloids, we know, have intermediate particles, intermediately sized, they're medium-sized particles. And we know suspensions have large sizes, and these happen to be separatable by gravity and by filtration. So if we look at our chart here, what we talked about here is matter. Matter makes up different substances. Those substances are made up of compounds and elements. The other type, instead of substances, we have mixtures here. Mixtures are going to be heterogeneous or homogeneous mixtures, and some of these can be separated through either filtration or colloidal, and we'll talk about distillation later. I'm going to end off this video here. There should be a second video attached. This will be over our second section of the notes over properties.